gonna just start? Oh, hey there, guys. Good afternoon. Today, so sorry. I'm gonna be talking about what Cartesi is promoting as a layer 2 and how it's gonna help people onboard more developers and how everything comes together in this Linux environment. I guess it's a little bit awkward and strange at first, especially because we're so used to EVM compatibility, solidity, and all that good stuff. But I'm gonna show you guys there's something else out there as well. So today I'm gonna introduce a little bit on how Cartesi Rollups work. And then I'm gonna show you guys how the interface is and how to program it for it. And by the end, I'm gonna show a few examples of things that have been built using Cartesi. So just as an introduction, this is a small example of a smart contract already using Python inside the Cartesi ecosystem. And it is here to just incentivize you to pay attention to certain aspects of it. By the end of the presentation, I'm going to go back to it, and I'm going to explain some of the lines that are more important over here. So the overview. Pretty sure you guys are already familiar with the Trilemma and what it means for Ethereum and what it means to the security of blockchain systems. But we all know that we need scalability, and we are trying to figure out how to make it work. And here I'm going to show you guys that it is possible to have complex computation and great tooling while developing smart contracts, only if you introduce back again a very important concept that we are forgetting: an operational system. So how does Cartesi make it work? Cartesi is an application-specific rollup. So it's an optimistic rollup dedicated to a single DApp. That means that you have the flexibility to change parameters and change how validation might happen depending on what it makes sense for your application. But at the same time, it means that you can have it as a layer and solution. So right now, the current system is EVM compatible, meaning you can deploy to any EVM execution environment. So it can be a layer 2, a layer 3, or whatever you think it makes sense. And the second part of the solution is the fact that instead of focusing on the EVM itself as the execution environment or WASM or something like that, Cartesi focused on bringing RISC-V to the fold. And what we did is create this machine emulator that is deterministic. And because the instruction set of RISC-V is very complete, it means that you can use any OS on top of it. And therefore, we chose to go with Linux, of course. So how does it feel, right? It feels like for all these years, we've been playing with flyers to make things work in the blockchain ecosystem. And when you try to use Cartesi, it feels like you have the whole tool set back. So it really improves the experience of developing applications. And this is how it looks like to actually be building your application. It's just a system of Docker containers that builds up to be the Cartesi node that you're going to develop for your application, meaning that you can just use any language, use any tooling, any of these things that we are used to have. So if you think it's interesting to have a Postgres database inside, you can have it. If you think it's interesting to have a Redis or to import frameworks such as OpenCV or large language models, we've seen examples doing that. And as long as you can properly build your Docker machine, you're fine. So that's what it means, right? Like it becomes very sexy. You can even import that 1-star repo that for some reason you're just so eager to. So to be fair and display a little bit of how it feels, I'm going to be very generous to the Ethereum network. And let's go with 30 million gas of block size, which is already not ideal. And if we take just the addition opcode, which is the least that does something, you can have about 10 million instructions per block, right? And this is what it takes to boot Linux. It takes 3.6 million CPU cycles to boot it. So it would never really be feasible, even interesting, to have Linux on top of Ethereum network. It's comparing apples to oranges, right? It does not make sense. They have different goals. And within 13 seconds, just to maintain some comparison, which is the block time on the Ethereum network, on a laptop such as this one, you can have 36 billion instruction cycles run. So that's a lot. That's a lot. Correction, guys. 3.6 billion. And that's how it looks like. The little black dot over there, it's the scale of what Ethereum does in 13 seconds compared to a single laptop running a Cartesi node for your application. So the rollups themselves, how the architecture looks. For people who are familiar with rollups, there's nothing new here. It's more for people who are trying to understand what it means to build a DApp using a app chain or application-specific rollup. So here you have a browser representing some kind of UI and interactions of the user. You're still going to be sending transactions to your base layer, represented by Ethereum over here. And this Cartesi Rollups framework, it really is the node with some other services that make it feasible and convenient to use, such as reading information for an Ethereum chain. But what you're going to be building is this Cartesi machine block inside. And we package it already ready to use with a HTTP API that will be convenient to make inputs and outputs to the base layer. And the DApp backend little box is what you're going to be coding. So you can code it in Python, in C#, C. You can code in brainfuck. You can use whatever, really. As long as you can do GET and POST requests to this API, it's going to handle the communication side of things. So it really is a sandbox environment. And as you build it, it can put anything inside. But as long as you remind yourself that it needs to be self-contained, it can run on Cartesi. So back to the code I showed you guys in the beginning. So this is a very simple smart contract. It's not smart at all, actually. It's an Echo Python example. What it does is whatever it receives as information, just plain text messages, it replies back using one of the output methods. So if it is a read request, read-only request, just like ETH call, gRPC call, you can recreate this report, they're kind of like logs. And if you have like actual transactions, they're changing transactions, you can create these notices. And notices are kind of like Ethereum events that have a Merkle proof attached to it. So you can go back to the base layer and actually do something about this information. Finally, not represented here, there is the concept of vouchers. And vouchers are transactions that will be able to be executed in the future. So you go on throughout the settlement period, execution period of your rollup, creating these vouchers. After you settle, they become executable because you have Merkle proofs attached to it. So going back here, you can see on lines 18 to 20 that I'm declaring some high-level handlers. These are the basic handlers every Cartesi application should have. You can create many more just as routes in an API. And these two high levels are the ones that I was talking about before. One is for read-only requests. The other one is for transactional requests. The read-only, it's really interesting because the node manages snapshots of the machine. So if you try to change anything on the application, it's not going to be saved. The machine continues pristine from the last transactional request. The same is true if you reject the input. So Because of the way EVM works, and it's interesting in blockchain systems that you'll be able to handle, let's say, weird corner case scenarios. So you always have the ability to throw in Solidity, right? And reject the input and still maintain the pristine state of your smart contract. Here is the same. After handling a transaction, you can send a reject response for the input, and the machine is going to be reverted back as if it never processed the transaction in the first place. So the idea here is to enable the dApps that we've been developed to be further decentralized, not necessarily needing to rely on off-chain computation or data sources and things like that. Also to have a faster development cycle and more concise and comprehensive by expressing more complex logics, by having the ability to import libraries and frameworks that many people have been building for so long. You have the ability to have extra processing power, so you can think, again, that you can use loops even and things like that. And you can leverage the traditional stacks because sometimes they're just nicer to use. And finally, as you're developing a new project, you gotta know that eventually your project might need new developers. And there's a very small pool of developers on Web3 right now. But it's easier to onboard Web 2 developers if you have a framework where they can use the language they already know how to code with. About the POCs. So at ETHGlobal Lisbon, we had this hackathon winner, ChangeEPT. This person was concerned about the open source large language models and what the influence large companies can have on them. And she just used a simple example, but like, what if Coca-Cola managed to mess up with the responses of the model, and suddenly you have like 10-year-olds questioning like, what is a healthy drink, and Coca-Cola is like the first response. How do you prove it if it's basically a random in essence, right? Are you gonna do some statistical analysis? How do you prove it replied to your children that kind of response? So she was like, okay, but if you run the inference in such an environment where you have validation process, you can prove that at that exact moment, the response was such. So what she did was she imported the alpaca model inside the Cartesi machine and ran an example showcasing the power of it. And the second one is kind of funny. Basically, there is these systems where you can clock in and clock out of factories or government institutions using Fingerprint. And in Brazil, people are pretty good at hacking this thing. Between silicon fingers and just bribing the person next to the machine, it's not really reliable at all. So this guy who was just trying to understand how Cartesi works thought it was going to be an interesting experiment to create such an application. He used OpenCV inside the machine to do the recognition of the fingerprint itself. And at the same time, he used a machine learning model that he built to check against forgery and spoofing. So with these two models running alongside, people can scan the fingerprints and, I guess, optimally in a more private setting, send this information and be auditable. If you guys want to know a little bit more about other examples, other projects that have been built using Cartesi, even games, we have a bunch of games being built with Cartesi Rollups. You can check rolluplab.io. People are sending their projects there. And also for this hackathon, we have such a distribution of prizes. We are track here. We're going to be throughout the whole weekend helping whoever is trying to build using Cartesi. Finally, pretty soon we're going to be launching a mainnet, a Honeypot Dev. The idea here is to showcase the security of the rollup. So the foundation is going to be depositing some amount of money periodically, increasing the amount of value locked, just to ensure, just to give insurance to people that there is something out there with a lot of money value locked, and nobody was able to hack it. So they're actually inviting hackers and security experts, white hats, other hats, to just try and steal this money. I'd say this is the end of this presentation. However, I have one more thing for you guys. So it happened a while back. Some guy was just trolling on Twitter asking, what if EVM in Ethereum is the global computer, why haven't we seen Doom running on it, right? And Eduardo, by the way, is he here? I thought he was here. He came here for a second, guys. You're gonna see him around. He just said, like, fuck it. Took a weekend and he ported Doom to the Cartesi machine. So this is actually running right now. You can stop by our booth and play a little bit with it. And the idea here is just showcase that even freaking source code that is like 30 plus years old can be built and compiled and run without major efforts on top of such an execution environment. Now, yes, I'm open for questioning. Any doubts? Okay.
Does Cartesi have any way to do cross-chain messaging for like how it was written, for example?
Cross-chain messaging?
Yeah.
With? Sorry?
So is there any way to like read the state of the Ethereum L1 or any other chain in this Cartesi version?
So he's asking if there is any way to read the state of networks within the Cartesi machine. But more specifically, you're looking for cross-chain stuff, right?
Yeah.
Okay. So yes and no. So the rollup itself is attached to some base layer, so you can read the state from there, of course. Mostly, the current state of the SDK is that you just get the messages that are coming towards the rollups. But the idea is to have something like pre-image. We are calling actually the hashing device, where you can have a device inside a Linux machine where you can send it to it any hash related to the base layer and receive as a response the actual data. Because you have a proof for it, it's possible to do a verification game, a dispute game later on. So you can read from the base layer you attach to, but from others, there is no current solution under development. Any others? Guess that's it. I hope to see you guys around. We are here throughout the whole weekend. I'll be happy to help with any questions, any issues you have while you're trying to compile anything. Thank you, guys.